All right, in the last video, we were looking at lines of best fit. We've continued on with scatter plots. And so in the last video, we were looking at drawing a line through those, that array of dots, a line that would fit most of them. Okay, so we're going to continue on with that today, look at one more example. And to review what a line of fit is and what it looks like, okay, you have a scatter plot drawn. So you have all of these dots. Okay, notice they're all kind of going down and to the right, so that would be a negative relationship with the scatter plot. And then what they've done in red is they have what's called a line of fit or line of best fit. And what that is, the definition's right here. It's a line drawn on a scatter plot that's close to most of the data points. Now, if you can get that line to go through a majority of the points, that's the best option to do. If not, then what you want to aim for is to get around the same number of dots above the line as below the line. Okay, you see there's roughly the same number on either side. So you want that line to kind of go through the middle of all of that data. So the example we're going to look at, okay, you can just sketch this XY table. But it says the table shows the depth of a river X months after a monsoon season ends. Okay, and a monsoon is a period of heavy rain. So obviously, as time goes on and that monsoon season is over, your river depth is going to get lower and lower because you won't have all that rain anymore. And then Y represents the depth of the river in feet. So A says make a scatter plot and draw a line of fit. B, write an equation for that line. So as I go to make this scatter plot, there's my graph. Okay, so my x-axis is going to be the months, so I'm going to label that months. And then my y-axis is going to be the depth in feet. Now, my months go from 0 to 8, so I can just go by ones. And I'm just going to label every other one. As long as you know it goes by ones, you don't need to label every single one. But then I notice my depth goes from 5 up to 20. So I am actually going to go by twos. Yay. All the way up to 20. Now keep in mind these all go by twos as they go. Okay, now, now that I have that, you just need to plot all of your points on your graph. So 0, 20, over 0 up 20. After 1 month, it was at 19. 2 months dropped down to 15. 3 months was at 13. 4 months was at 11. And sorry, you hear Connor in the background. 5 months was at 10. Oops, have I skipped some? Okay, 1 month was at 19. 2 months, 3 months was at 13. Okay, 4 months was at 11, so I forgot that one. 5 months was at 10. 6 months was at 8. 7 at 7. And 8 at 5. So here's my scatter plot. Doesn't go in a perfect straight line, but it is awfully close to it. So whenever I go to draw my line of fit, I want to make sure that it kind of covers a lot of these points. And if you notice, kind of right through here is really your best option for your line of fit. So I am maybe going to start right in here and just kind of try to hit as many points as I can. And that line's not straight at all, but you get the point of it. Okay? And then B says to write an equation for that line. Okay? Now I'm going to flip over to the next screen where you actually have the graph that was made in the book, and it'll look a little cleaner. So here's a graph, okay, river depth, and it looks very similar to ours. Okay, they went by 2s, they went by 1s. But the first thing I need to do is I need to write the equation for this line. So remember, this is back on part B. Our equation is going to take this form, y equals mx plus b. B is your y-intercept. Where does it cross the y-axis? So if I look at this one on theirs, it crosses up at 20. So I'm going to use 20 as my y-intercept. The only other thing I need to figure out is what the slope is. So I notice, and they have them labeled right here, but their graph goes through the 0.510 and the 0.68. So to figure out my slope, I'm just going to use rise over run. So if I start here, I rise, I actually come down, so it's going to be negative. Now, be very careful because remember, your numbers go by 2s. So even though you're only going down 1 box, it's actually you're going down 2. And then you're going over 1. So your slope is negative 2 over 1, which is just negative 2. Now, part C, interpret the slope and the y-intercept. So the first thing I'm going to do is my slope. My slope is negative 2. Okay? Well, we're talking about the depth of a river over a certain amount of time. So the fact that this is negative, think about what that means. That means the river is actually dropping. Okay? So when we interpret it, what does it mean? The river is dropping 2 feet each month. And those were the labelings that they gave us. The y-intercept, on the other hand, was 20. And remember, your y-intercept is essentially your starting point. Okay, so that was 20. So the river was 20 feet when the monsoon season ended. That's when they started keeping track of everything. So you've really got to take into consideration what the problem is talking about. And that's going to play into your interpretations of everything. Now the last part, part D, is to predict the depth at month 9. Okay, so we can do this in 2 different ways. We can use the graph, okay, and at month 9, it looks like it was right here, and that was at 2 feet. We could use that as a prediction. Or if you don't have a graph, or if your graph is not very easily read, okay, like if I were going to go back to the one that I drew, it wouldn't be very easy to read. Okay, 1, my line wasn't straight, and 2, it was just kind of sloppy. So we can use your equation to do that. So our equation was y equals 2x plus 20. So if I'm going to use this, month 9, remember, month was on your x-axis. So that 9 is actually going to go where the x is. So I just replaced the 9 with the x. Negative 2 times 9 is negative 18. Plus 20 is 2. So you see we get the same answer, whether we use the graph or whether we plug it into the equation and solve it from there. So that wraps up our notes and our lessons on the lines of best fit for a scatter plot. So refer back to your Canvas page for your assignment.